So far, we've enjoyed mathematics from basic counting to calculus, just counting 0, 1, 2, 3, all the way to studying change, visualizing it in two dimensional, three dimensional space with matrices, vectors, understanding statistics, probability, trigonometric equations, everything. Now it's time to understand certain constants. We'll start with pi, which is the ratio of circumference of any circle, small or big, by its own diameter. This has confused so many people in the past. They were all trying to figure out what is the best expression for pi, where will it end, and will it end at all. And you have any circle, this ratio of circumference to diameter was pi, and this was enough to prove that any circle that you're drawing right now is imperfect. It is just an approximation, because 2 pi r, you can never complete that circle and say this is 2 pi r, right? So now the next number that we'll introduce, the next constant that we'll introduce is E. E is a special number which is nothing but interest. What is this constant called 2.71 blah blah? It is compound interest. Why should you raise e to the power of something and say e to the power of 5, e to the power of pi, this, that? Is because this particular number has a special property that if you start with 1 rupee and you accumulate interest over it, let's say for 1 year, saying 100%, you would have to give back 2 rupees. So 2 has come, but 2 is just not enough. If you say that only 6 months I'm going to give you back your 1 rupee, what is the new interest rate? And if the loan guy says it's 50%, then you're saying that 1.5 you might be fine, you would have given it back in 6 months and you're happy. But let's say you did not, you compounded to 0.75 plus 1.5, it would become 2.25 while it was just 2. It became worse. And will it get worse further if you were doing this compound interest every month divided by 12, which is 8%, or every day, which is divided by 365, so on and so forth? If you did it all the way to microsecond, millisecond, if you compounded for this 1 rupee, you would end up with this magical number called E. And mathematically expressed as compound interest is 1 plus 1 divided by n to the power of n. As n tends to infinity, it trends towards this magical number called E. To understand why you are raising this to another number called pi, 2 pi, we have to understand complex space a little bit better. What is complex numbers? Square root of minus 1 does not have a real value, so you dedicate it as a new constant called I. I squared is minus 1, alright. I to the power of 3 is minus I, alright. I to the power of 4 is 1, but why? Where is this I coming from? I is nothing but you are rotating a specific vector along the y-axis by 90 degrees. You're rotating, I shouldn't say by y-axis, but rotating it by 90 degrees. Let's assume x-axis to be real and y-axis to be imaginary. And visualize a unit circle which passes through the points 1 in the real plane, I in the imaginary plane in the y-axis, minus 1 in the x-axis, and minus I in the y-axis imaginary plane. You are going around the circle, you are multiplying by I. From 1 you went to I, you just rotated by 90 degrees, and you further rotated by 90 degrees again, you came to minus 1 in the real plane, and you rotate by I again, which is multiplied by I, you get to minus I, and then you come back to 1. This is extremely useful when you do signal processing and Fourier series understanding in the next videos. So now, where is this pi and 2 pi coming with this I is because your 2 pi radians make 360 degrees, which is one rotation all around this beautiful unit circles. Next is, when you talk about pi, you say it is infinite, but has anyone ever given an expression for it? Look up on Google who gave the first expression for pi. It's Madhava series, also called Leibniz series, within brackets 300 years later, is an expression of pi, the first beautiful expression of pi. Who conquered infinity to give this is Madhava of Sangamagrama, which is in Wikipedia today. So now, which brings us to the point that even when you add things to infinity, 1 minus 1 by 3 plus 1 by 5 plus dot 1 by 1 factorial, this, that, and everything to dot 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 dot, certain series converge, and there could be mathematical tricks done to prove that these converge to specific values, which could be extremely useful. From there on, we are jumping to a beautiful concept of Euler's formula, which serves as the foundation Fourier series. What is Euler's formula? E is the number that we talked about, to the power of 2 pi I. 2 pi I, which means you're rotating in the complex plane, you're growing from 1 to E 2 pi times fast, certain times very fast. E is a special number. E to the power of 2 is twice as fast as E. You're going from 1 to E twice as fast, thrice as fast. So 2 pi I as fast is rotating along a new plane, and you've come back to -1. That's the beauty of these Euler's formula. So now it would start to make sense why the complex plane is important, where E, pi and I are doing this beautiful magic for you.